So the last thing we're going to do here is talk a little bit about larger determinants, as it were, where the process actually doesn't change that much. Our goal here, much like in the 3x3 case, is to use minors to expand our way down to things that are more manageable. If we get lucky, we run into cases where our minor is in a nice form. For example, the book doesn't talk about this, but if you have anything that is called a triangular matrix, that is, you've got sort of a system of triangles in one corner and zeros in the other, that will have a determinant defined by its diagonal. But if you don't get a nice pattern like that, what you have to do is just work your way down to a 2x2 system, however many pieces that takes. If you have a 4x4 system, then you're going to reduce along one row or column to get 4 3x3 systems that will each have to be then taken down to 3 2x2 systems each. And you can see how this gets to be kind of absurd, which is why I'm not going to ask you to do anything in here with a system that large, at least not in full detail. The main thing we're just going to have to look at here is how we can understand the process in terms of developing that recursion a step further. That is, set up what sort of minors we'd want to look at. So for example, if we want to look at the cofactor expansion for something like the 4x4 determinant 3, 4, 1, 2, 0, 2, 1, 0, negative 2, negative 1, 0, 4, 1, 3, 1, 5, our logic is roughly the same as it was before. We want to maximize zeros because those give nice cofactors. So we're going to look at the second row, 0, 2, 1, 0, because it's the only one that has two zeros in it. And expanding along there, we are going to get for our determinant 0 times negative 1 to the 2 plus 1, multiplied by the determinant of 4, 1, 2, negative 1, 0, 4, 3, 1, 5. Hopefully we know what happens there. Plus 2 times negative 1 to the 2 plus 2, multiplied by the determinant of 3, 1, 2, negative 2, 0, 4, 1, 1, 5, which we've seen a couple times now. Hopefully we know what happens there up to that cofactor. Plus 1 times negative 1 to the 2 plus 3, multiplied by the determinant of 3, 4, 2, negative 2, negative 1, 4, 1, 3, 5, which we don't know, and is not going to be a very nice determinant to compute, but that's what we're working from. Then plus negative 1 to the 2 plus 4 times 0, multiplied by a determinant that doesn't matter because we're multiplying it by 0. So hopefully taking that whole thing out, you can see what happens to two of the terms pretty quickly, and by luck, we know what happens to another one, but we still have one more 3x3 that we have to do all the way out because it's not in a nice arrangement. And it doesn't have any nice pieces to expand around. So that's going to be a fair amount of work, which is why I don't feel that strongly about making you go through the steps of doing one of these problems in complete detail. I'm more interested in seeing that you know how to make those cofactors appear in the right way. But if you're curious and if you're willing and able to get through all that stuff and do the right addition and multiplication, you should end up with the determinant that we're looking for there being surprisingly equal to just 1. But I'll leave that to you to check. And that's it as far as material goes for this chapter. In our next chapter, we are going to be dropping back down to number 4. We're going to be talking about stuff that's more traditional to a pre-calculus class. That is, we're going to be getting into trigonometry. But that's stuff for a couple weeks from now. For now, happy studying, good luck on the exam, and you're welcome to contact me if you have any questions about that as we're finishing up.